Let's continue.
The second concept I would like to review is the system concept. To say something is a system is almost like a cliche. But to a super analyst, system thinking is anything but a cliche. Okay. The terminology I'm about to review is going to inform us now how do we scope analysis work and about what to analyze. Let's switch to PowerPoint for a moment.
There are several key points I want to review about the system concept. First, we should recognize that there is always a hierarchy of subsystems. Now, we cannot consider the whole thing as one system because then we cannot parse it and analyze it. So, for example, a company is in a subsystem inside and a business ecosystem. Together with many business partners, there are also subsystems and they form a business ecosystem. And within the company, there are many functional departments or business processes that together constitute in a system as a company. Okay, let's take a look at the example of the DSO. Within the cloud boundary is the business ecosystem for the DSO. So my company operation is the company, but the company interact with like government, the regulatory bodies, vendors, and insurance carriers, the banks, etc. On a very intense daily basis to conduct the business. These are not just concepts, but they are hard system connections. Well, let's take a look at the DSO's internal information architecture and how it interacts with business partners' systems. The rectangle box here is the company boundary. Now, each of the green boxes inside the company is an application that has some external connection. For example, the internal accounting portfolio applications interact with the bank every night. The patient loan system inside deal with the external credit agencies all the time. And then you have information service providers, and you have dental insurance companies, and so on. So this is why we need to look at an ecosystem of subsystems, because one project may be about one subsystem, but it's going to be related to other subsystems. And later on, that's the foundation for our analysis of the project scoping. The second key point we need to keep in mind is there are components in a subsystem. Now here you may ask and say, why you call something a component and something else a subsystem? What's the difference? Where's the boundary? Well, there's no precise scientific answer, but here's my take. When I say something is a component of a system, what I mean is it cannot deliver value to the outsiders alone. Well, let's take an example of an HR application. Okay? If a person inside the company wants to make an inquiry about an employee, now he or she needs to contact an HR person or HR user here, let's say. Now that person will need to use the HR application to get access to the HR data and then get back to the person with a question. Now in this case, data, application, HR users are all components of the HR subsystem because no one alone can answer the question. The third key point about a system concept is there are connections. Components are interconnected to make a subsystem work, and subsystems are connected to make the business ecosystem to work. Now this is an important foundational point that we keep in mind, because later on when we analyze the project scoping, the connections is the key to unlock that analysis.
project scope defines what's in scope for analysis. Now, this is obviously a critical question to answer. You've probably heard the term scope police. Everyone on a project is trying to harden the boundary of a project. And a robbery project boundary is an invitation for trouble, no question about it. So how to define in a project scope? Senior analysts or other analysts typically work within the defined scope. Only the super analyst lead the analysis of scoping. So, knowing how to approach this will truly show the value of you as a super analyst. This question of analysis scope is directly tied to the concept of subsystem boundary.
Let's take a look at some of the special characteristics of project scope. Project scope is often defined along some administrative or operational boundaries. For example, it can be function-oriented, like an HR project or a sales project. It can also be defined by business processes, for example, in CRM. And this kind of things is often cross-functional. Now, oftentimes, project scope can also be defined based on some discretionary concerns. For example, now this is the work we just got funding for, or the company just bought an application and allocated funding for any changes necessary to use that application. And that becomes the default scope for the project. But these boundaries oftentimes becomes hard to maintain due to connections among subsystems. Remember, subsystems are often connected, and so sometimes one change in one subsystem may trigger necessary changes in other subsystems. So the question is, what are they? Now, this is an important question to answer before the starting of the project, because due to managerial jurisdiction differences for the subsystems, it is very hard for a project team to easily scope in or scope out these changes on the fly. So it is important to answer the first question as well as you can, and then define the project scope by incorporating that. In this case, the super analyst does not make scoping decisions, but he or she will play the central role of decision support here.
Now, how do subsystems connect with each other? That is a critical question. Now, obviously, I cannot describe specific connections among specific subsystems in a particular context. What I can do is to introduce in a conceptual framework that's going to serve as a reference point for you in future analysis. Now, let's switch to PowerPoint for a while at this point.
Generically, subsystems can be connected in one or in a combination of the following three ways. First, two subsystems can be sequentially connected. Well, let's take a look at two subsystems in a DSO company. The first one is the clinical subsystem, which treats patient. Once a patient has gone through that subsystem, one of the output it's going to generate is the production items that were performed on the patient. And that will serve as the input to the next subsystem, which is the insurance claim fighting subsystem. Now, these two are sequentially connected because you can't start the second insurance claim process before getting the output of production items. Second, two subsystems can be parallel connected. Now, in this case, let's examine two common subsystems in a production environment. For example, in the process of generating a new product, and you have two critical processes, R&D and production line reconfiguration. Now these two subsystems work in a different way. Instead of you finish one and then start the other, but these two constantly provide mutual feedback to each other. This is based on the popular principle of engineered to be manufacturable. Subsystems can also have an pooled connection. Well, let's take a more generic example here. For example, if your company having a sales team, one of the salesperson creates a customer record in an enterprise database, and that customer record subsequently will be used by many people for different purposes at different times. Now, as we can see, at the time of the record creation, then no one can predict all these different uses and timing of that record. So that is why there are pooled connection. That I put something into a pool, which is a resource pool that everybody can tap into. And whoever needs to use it for whatever purpose in the future, they'll just go ahead and use it. And that's called a pooled connection. Now, armed with the above knowledge, a super analyst can systematically analyze and changing subsystems outputs, trigger conditions, and their potential client subsystems to define the connections. And this will serve as a base for project scoping analysis.
That's in a dense episode, right? Let's stop here. In the next episode, I will lay out a comprehensive set of generic analysis agenda. I'll see you next time.